We are here today to talk to you about ants. But really, our mission is to inspire you to take a moment to discover and appreciate beauty hiding in plain sight.
Over the past 2 years, our personal experience has been that nothing has really changed. But in a way, everything has changed. The world around us is no different. But what we have discovered in our own backyard has changed the way we look at it.
We've had the opportunity to appreciate the diversity of ants, from the wooded forests of Pennsylvania to the rolling mountains of the Sierra Nevadas and the white sandy beaches of South Carolina.
Ants, as we know them, are tiny, creepy bugs that hide in your cereal boxes or live in your walls and don't even bother to pay rent.
But really, ants are much, much more.
Ant colonies are intricate civilizations that are made up of thousands of individuals who live together without dispute or conflict. In fact, their societies are incredibly similar to ours, with hierarchies, armies, and even agriculture.
Our passion for studying the world of ants has prompted us to interact with nature at an intimate level and allowed us to appreciate the wonder in everything.
To help you understand the sheer magnitude of this magnificent society, let's look at a few figures.
The society of ants evolved over 92 million years ago, making it nearly 600 times as old as our own, which evolved less than 200,000 years ago.
There are over 12,000 recorded species of ants and less than a dozen recorded species of humans. For example, Homo sapiens is one of the 8 species of humans in the genus Homo.
There are an estimated 10 quadrillion ants on the planet, compared to the United Nations' recent estimate of a mere 7.5 billion people.
That's about 1.6 million ants per person, which in of itself is pretty hard to comprehend. Okay, so our story began 4 years ago in a middle school science classroom with walls lined with beautiful textbooks and posters about the anatomy of frogs hanging from the windows. Picture a small, fascinated 8th grader hunched over a glass case in the corner of this room. He's staring at hundreds of ants, all running around, scurrying this way and that. He quickly jots down a few notes and then gently puts the case away. He's embarking on a project to explore the behavior of ants under different conditions. But little does he know, he received a generation of worker ants that will refuse to cooperate, and his experiment will fail, regardless of his efforts. This fascinated, curious kid gaping in awe at a few hundred ants was me, beginning to discover my love for this beautiful, sophisticated world. So 2 years ago, I tried to revive this project, this time with my brother's help. But early on in the experiment, we realized that we would need many more ants than we previously thought. Since workers have lifespans of only a few months, we would need to replenish our supply quite often, and we didn't quite have the patience nor the resources to buy as many ants as we wanted. So after doing some research, we discovered that we would need a queen ant. Queen ants live anywhere between 8 and 30 years, and they constantly lay eggs. So their workers essentially replace themselves every 4 to 6 months. This means that throughout a queen's life, she gives rise to a seemingly infinite number of ants. And each of these ants serve to assist the queen and improve the overall health of the colony so that it may live longer. In fact, ant colonies are often referred to as superorganisms. Just as human cells have specialized roles to help the body, workers have specialized roles to help the colony. And similar to skin and blood cells in the human body, the workers are replaced every few months.
Now, we would actually need to catch a queen. Instead of digging up an established population to reach the queen, we learned that there are natural ways of doing so. As it turns out, mature wild populations of ants actually produce winged male and female reproductives called alates. When the conditions are just right, the colony sends out these reproductives to mate high up in the air, a process known as a nuptial flight. These flights occur during specific times of year under specific environmental conditions. For example, we learned that certain flights occurred after several days of rain or under certain relative humidities. Once mated, a female elate falls to the ground, sheds her wings, and begins searching for a spot to dig a founding chamber, a safe place with a constant humidity gradient where she will remain for the duration of her life, producing and protecting her eggs that will eventually become workers. All we would need to rear a colony was the queen, and we would need to catch her after a nuptial flight, but before she began to dig a founding chamber. So our goal was to capture a newly mated one and help her raise workers and start a family.
So after we learned about these nuptial flights, we were eager to find one. Once a mated queen sheds her wings and digs a founding chamber, she seals the entrance, lays eggs, and waits for up to half a year until she has her first generation of workers. During this time, she does not eat at all and barely moves around. But when the first workers emerge, they open up their nest entrance and begin to search for food. So, in order to replicate this natural chamber, we created test tube setups, artificial environments that simulated a queen's founding chamber by providing a humidity gradient and enough space for nearly 24 workers once they emerged. But unfortunately, after a few months, without any success, we nearly gave up hope on finding a queen. Finally, while walking our dog in June of that year, hardly looking out for a nuptial flight at all, we were pleasantly surprised to stumble upon a huge Carpenter Ant Queen. After putting her in a test tube setup, I watched as she laid eggs, and as those eggs slowly grew to larvae, and as those larvae to workers over the course of the next couple of months. And by the time the first generation of workers had fully eclosed, I felt a sense of pride that I would have never before associated with keeping ants before. By helping this queen, I allowed her to bring life into the world, and the process of doing so was truly rewarding. So this experience inspired us to continue to catch queens throughout the summer and into autumn.
Whenever we caught a queen, we kept her test tube in a dark place like a closet, which simulated an underground environment.
And when the queen had her first generation of workers, we needed to feed them. So my brother and I used old containers and mason jars to collect crickets we found outside.
The crickets were an abundant and nutritious food source, but we would need to freeze them after they were caught to get rid of any parasites or mites they could potentially pass on to the ants.
We were perfectly fine with it. But when we told our parents, they were a little hesitant that we were keeping Carpenter Ants in our closets and crickets in the freezer.
We became fascinated by the process of raising an entire civilization. We learned how to attract and identify many kinds of ants and how to provide customized living conditions for each species. The more we learned, the more there was to explore. Once autumn had come to an end, it was time for us to wrap up our field work, as the ants outside had sealed up their nest entrances to prepare for hibernation. We would have to wait some months for nuptial flights to start up again in the spring, but this gave us an opportunity to do additional research on our native species. We used this time to learn to identify ants down to the species level, and what characteristics differentiated one from another. In some cases, a mere glance at an ant is all you would need to determine its species. Black carpenter ants, for example, were the largest in the area and very recognizable. Other species required the exact number of hairs to be counted on particular sections of their bodies under intense magnification. For example, workers from the species Chromatogaster cerasi have 2 erect hairs on their thoraxes, compared to the many erect hairs that Chromatogaster lineolata have. We developed a process where we first used our camera to identify ants down to the genus level, and then a microscope to identify them down to the species level. We used guides described by world-renowned myrmecologist E.O. Wilson of Harvard to help us distinguish the species. Before we knew it, it was spring and time to put our skills to the test. We set out what we considered traps for the ants, which were really just cookie crumbs on index cards scattered around our yard. We observed which ants regularly visited the traps and spent most of our time trying to identify them. Within a couple of weeks, we had already identified 26 species in our yard alone, compared to the 3 or 4 we were expecting. Several of these species were very rare and even had little to no professional documentation in Pennsylvania. Among the most beautiful ants we photographed in our yard was Camponotus nearticus, a sophisticated species of carpenter ants with advanced nesting habits, whose workers were an iridescent black with deep shades of blue and violet. One day, in late April, my brother and I woke up early to check on some traps we had set out the night before. We found what looked like a mix between 2 relatively common species in our yard. I couldn't immediately identify it, and I was curious as to what it was, so I picked up a worker in a small vial and stuck her in the fridge for a few minutes to calm her down. When I took her out, I used various keys and guides to try to identify her, but I couldn't seem to figure it out. I reached out to one of my good friends who's an expert in the field and sent him some detailed images of the ant. He identified it as a minor worker of Colobopsis mississippiensis, a very rare species known as the gatekeeper ant, native to Mississippi. This species, like many others, had 2 kinds of workers, miners who lived deep inside the nest and helped the queen tend to eggs, and larger major workers, also known as soldiers, who were typically in charge of capturing prey and protecting the nest. There was a reason I couldn't identify the ant I'd captured. It was a miner. Although the miner worker I'd captured was small and discreet, the major workers of this species were very distinctive. Not only were they larger, but their flat heads were designed to match the bark of the ash trees that they lived in, so they could plug up their colony's nest entrances and act like living armored doors. Now, I was a little hesitant to draw any conclusions based off my friend's advice, especially considering that the species was supposed to live in the South, not in Pennsylvania. I put this in the back of my mind, and we continued to document the rest of the ants in our yard until early June, by which time our school year had just ended. My brother and I came home after our last final exam, and something on a tree caught our eye. It was a major worker. The ant had a flat, reddish head and was undoubtedly a gatekeeper ant.
This was amazing. We learned that gatekeeper ant colonies do not produce major workers until they're over 3 years old. So, not only did the discovery of the major worker allow us to confirm our identification, it also meant that the species had been established in Pennsylvania for quite some time, and went on to suggest that these ants could in fact be native. This was one of the most inspiring experiences in our time researching ants. The discovery of this species in our own front yard changed the way we looked at the society of ants. Over the past summer, we had the opportunity to visit California and Georgia.
In the Sierra Nevada mountains, we found large, armored ants that preferred high altitudes and low oxygen. While in Atlanta, we found small, delicate ants that enjoyed the humidity and intense heat of the South.
And although we found these exotic ants fascinating, when we came home, we gained a new level of respect for our native species, as we realized how truly beautiful and unique they were.
Through our experience, we were able to take a step back from our phones and computers and allowed ourselves to become immersed in the wonderful world that we live in.
We've learned a lot about ants, but we've learned even more about ourselves.
We learned that a passion for anything could change your perceptions of wonder and beauty.
We learned that there is beauty all around us, if we could just take a moment to notice it.
Many times we feel that awe-inspiring experiences should involve expensive trips to exotic locations and faraway places, but all we had to do was step outside.
The past 2 years have been tremendously eye-opening for us, not only because we discovered an elegant, sophisticated world outside our front door, but because we took the time to step away from technology and appreciate the natural beauty around us. Through our experiences, we've cultivated a wealth of knowledge and gained an extraordinary set of skills that we would have never known about if we had not discovered the magnificent world of ants. We've been able to learn about indigenous species and how to raise a colony from a single queen. And from our work, we've been fortunate enough to meet renowned experts in the field. Out of our love for ants, we've had the opportunity to help others discover this beautiful society and have given them the chance to see firsthand the incredible opportunities that can arise from slowing down to appreciate the beauty of the natural world. And although watching an ant colony can allow one to immerse themselves in nature, there are countless other forms of beauty that are readily accessible to pretty much everyone.
In fact, beauty can be found everywhere, throughout the world.
To find it, we simply need to take a moment to disconnect from technology and connect with our surroundings.
If you've ever had a desire to learn more about nature, whether it be about a flower in your backyard,
Or bats in the night sky.
we would like to encourage you to take a little time out of your day to explore your interest.
You'll be astonished by what you find.
Thank you.